In today's lesson, we are going to be looking at trigonometric identities. So you might be thinking, well, what is an identity? What does a trigonometric identity mean? Well, an identity is an equation that is always true regardless of the value of the variable. And then, so why do we learn and practice them? Well, it helps explain aspects of the graphs of trig functions, which we are going to be looking at in the next unit. It makes you think, it deepens your understanding, it broadens your experience, it lays a foundation for further conceptual depth and increasing maturity. In a word, it's educational. Right? A lot of math, or not a lot of math, but some math at the higher levels comes down to just proving that something is what it is. Right? Coming up with a mathematical expression or an equation to basically prove that something is equal to what we say it's equal to. Right? Coming up with different equations, things like that. Different ways, like say, think of like sum of squares, the Pythagorean theorem. Right? There are different proofs for why that works or why that is what it is. Right? So that's kind of what we're doing here as well. So some of the fundamental trig identities. So these are some of the things that we are going to be using to help basically prove that certain statements are what they are. Right? So we have cosecant, or we have our reciprocal trig identities. Right? So this is basically using that idea of the reciprocal ratios. So cosecant is equal to 1 over sine, secant is 1 over cos, cotangent is 1 over tan. Quotient identities, so sine of an angle over cos of an angle equals tan of an angle. And the Pythagorean identities, sine squared theta plus cos squared theta equals 1. So these are some of the identities that we are going to be using. Now, for proving some more complex identities, some things that we're going to look at, right, or what we can do, we can use the squared versions. So we could square cosecant and square the sine, square secant, square cos, square cotangent, and square tan. We could square the quotient identities. So sine squared theta divided by cos squared theta equals tan squared theta. And then we can rearrange the Pythagorean identities. Sine squared theta equals 1 minus cos squared theta, and cos squared theta equals 1 minus sine squared theta. Along with those changes that we could make to those general identities, right, there are some tips that we could look at. So we could try, or we want to try to change everything to sine or cosine. Right? We want to kind of remove tan, cosecant, secant, cotangent from our from the expressions. We want to try to deal with everything in sine and cosine. If we have fractions being added or subtracted, make sure we find a common denominator and then combine the fractions. So we don't want to have multiple fractions. We want to kind of combine everything as we can. Use difference of squares, right? So I might be able to cancel out some terms or simplify some things using difference of squares. So for example, 1 minus sine squared theta isn't a difference of squares. Those are both perfect squares. So I could break that down into 1 minus sine theta times 1 plus sine theta. I can also use the power rule. So sine to the power of 6 theta is the same thing as saying sine squared theta to the power of 3. Right? So multiplying the exponents there. So similar idea. So I could use power rules. Right? And again, sometimes it just comes with playing around with the expressions and seeing what we come up with. So there might not. So you're going to use these tips, but sometimes it might just be playing around, and as you do more and you practice more, some of it becomes a little bit easier. So the first thing we want to do is prove that cos theta times tan theta divided by sine theta equals 1. And so when we're proving identities, we want to basically split it up into a left side and a right side. Right? So basically left side of the equal sign and the right side of the equal sign. And basically we're going to try to get it so that the left side and the right side are the same thing. Right? We are going to want to include, we want to kind of reference those trig identities that we've looked at or that we mentioned previously. So I'm going to pull those up here. So we can see them kind of in the bottom, right? So again, right side right now is easy. Right side just equals 1. There's nothing else we can put there. The right side just equals 1, right? There's nothing else I have to do that. It's as simplified as it's going to get. The left side, we have cos theta times tan theta divided by sine theta. And our goal is to get this left side to equal the right side. So I want to somehow change cos theta times tan theta divided by sine theta to get us 1. Well, let's see what we can do. Right? First, one of our tips was to kind of get rid of tan. Right? We want to have cos and sine only. So let's get rid of tan. And we can do that by using our quotient identities. Right? We have our quotient identities here. You see it kind of pop up these quotient identities here. Because I can replace tan theta with, I'm just going to say qi. So quotient identities. So I can replace tan theta with sine theta over cos theta. So I'm going to have cos theta times, instead of tan, it's going to be sine over cos. And that's still all divided by sine theta. I can simplify this now because if I'm multiplying cosine by sine and then dividing by cosine, the cosines actually cancel each other out. I'm left now with just sine theta over sine theta, which equals 1. Right? It's the same thing on the top, same thing on the bottom. Sine theta divided by sine theta equals 1. So now when I look at my left side and right side, they're both equal 1. So left side equals right side. So I've just proved that cosine theta times tan theta divided by sine theta equals 1. And that's what we're doing with these trig identities. That's what we're going to be doing. The next one, we want to prove that tan squared theta plus 1 equals secant squared theta. So, okay, now we're introducing some of our reciprocal ratios. Let's kind of bring up our trig identities. We are dealing with the squared versions of them, so let's look at the squared versions here. Zoom in a bit. So again, I'm going to split it up into a left side and a right side. So the right side is just secant squared theta. And on the left side, I have tan squared theta plus 1. Can't do anything else with that right now. Right? So left side and right side. So I need to somehow get these to equal the same thing. Well, secant squared theta, right? Let's use our reciprocal identities. And let's convert this into, we can see the reciprocal identities, right? So secant squared right over here will become 1 over cos squared theta. So that's good. Let's leave it there for now. Because again, we want to get things to sine or cosine. We have it as cosine, so let's kind of work with the other side now. I have tan squared theta plus 1, right? I want to get rid of the tan squared, right? So I'm going to use my quotient identities. So instead of tan squared, I can rewrite that as sine squared theta over cos squared theta plus 1. I'm adding fractions here, right? I have a fraction, I'm adding it to something else. So we did mention one of our tips was to get a common denominator. So a common denominator, I need to have cos squared theta, so sine squared theta over cos squared theta is equal to cos squared theta over cos squared theta. Right, so just rewriting that there. Right, got a common denominator because now I can add these two fractions together. I have sine squared theta plus cos squared theta, all divided by cos squared theta. And when I look at this, I can't cancel anything out, right? Because we're adding fractions, or we're adding, right? So if we go back to like kind of our radical terms, I can't, or simplifying rational expressions, I can't cancel anything out here. But I should recognize that sine squared theta plus cos squared theta is one of our identities. So if I scroll back up to look at our identities, it's this identity right here. So we do have a scenario where I can replace, using the Pythagorean identities, so I can replace sine squared theta plus cos squared theta with 1. So I end up with 1 over cos squared theta. And if I look at the right side, that is also the same thing that I had. So I now have that left side equals right side. So I've just proven that tan squared theta plus 1 equals secant squared theta. Let's move on to the next one. Cos squared x equals 1 minus sine x times 1 plus sine x. So again, I'm just going to start by breaking them up, writing out the left side, cos squared x, and on the right side, 1 minus sine x times 1 plus sine x. So where can we start? Well, let's pull up our trig identities and see what we can use. Cos squared x, okay, can't really do anything with that. Right, it's already in cosine. If I look at my right side though, it does appear to be a difference of squares. Right, so I can actually go through and simplify or multiply these together, and I get 1 plus sine squared x. Oops. Sorry, not 1 plus, sorry, 1 minus. 1 minus sine squared x. Okay, so I'm dealing with squared, so let me go down and look at some of my trig identities that have been squared. I do have a cos squared x here. And oh, it does happen to also be the exact same thing that I'm looking for. So in this case, cos squared x, right, I can use the Pythagorean identities. Cos squared x is the same thing as saying 1 minus sine squared x, right? Even though in our example it's x, here it's theta. Again, that's just representing the angle, so x is representing our angle, so x and theta are interchangeable in these identities. We could have another letter to represent the angles as well. So now I have the left side equals the right side. I don't actually have to do anything further, right? So this is just a quick look using two identities to kind of convert. Left side equals right side. I've proven that cos squared x is equal to 1 minus sine x times 1 plus sine x. Example 4. Okay, now we're getting a little bit more complicated. So 1 minus cos squared x equals sine theta, or sorry, 1 minus cos squared theta plus sine theta, or sorry, equals sine theta times cos theta times tan theta. Cool. All right, so let's start off with our left side. Let's just write out our left side, 1 minus cos squared theta. On the right side, we have sine theta times cos theta times tan theta. If we're not sure where to start, right, I'm going to bring up our trig identities. We're not dealing with anything squared yet, so I'll go back to some of my kind of more base ones. I do have a tan on the right side, so I do want to get rid of that. Right? We did say we want to deal with sine and cosine primarily. So I'm going to use the quotient identities. this middle one here to get rid of that tan. So we have sine theta times cos theta times, instead of tan, we have sine theta over cos theta. I'm going to keep playing with this, keep going through, because if I'm multiplying by cosine and dividing by cosine, these will actually cancel out. So I'd be left with sine theta times sine theta. I can actually multiply those together and become sine squared theta. Can I do anything? I can't really do anything further. I'm dealing with squareds now, so let's move down, look at the squareds. Oh, well, I could actually, either one of two things I could do, right? Sine squared theta, where do I see that? Well, I see it, it's not in a fraction. We don't want to go back to tan, but we do see it in the Pythagorean identities. So what I could do, right, because I do see that sine squared theta equals 1 minus cos squared theta. Or, right, so what I could do is I could use the Pythagorean identities on the left side and see that, oh, well, that's what I have on the left side is the exact same thing as sine squared theta. Or on the right side, again, I could have used the Pythagorean identities to change the sine squared theta to give me 1 minus cos squared theta. Either way would give me the same thing, but we'll change the left side just to give us more practice changing these. And now that I look at the two left side and the right sides, they are equal. So again, I've proven that this statement is true. Example 5. This one is a little bit more, a little bit more challenging. Again, just kind of looking at different examples. So sine to the power of 6 theta equals 1 minus cos squared theta to the power of 3. Again, I'm just going to separate left side and right side first. So sine to the power of 6 theta equals, and then on the right side, 1 minus cos squared theta to the power of 3. So one side has sine, one side does not. Right? I'm going to want to kind of get sine or something similar on both sides. Right? I do have the Pythagorean identity similar to what we just looked at. So I'm going to use that to rewrite the inside of this bracket. So 1 minus cos squared theta becomes sine squared theta, all to the power of 3. Just using this Pythagorean identity here to just rewrite everything as just sine squared. But it is still cubed, right? So I can actually use my power laws to rewrite this as sine 6 or to the power of 6 theta. And if we look at the left side and the right side, it is the exact same. So we have proven this statement as well. We've shown that sine to the power of 6 theta is equal to 1 minus cos squared theta to the power of 3. Last example, right? So we have sine squared x divided by 1 over cos x equals 1 plus cos x. So I'm just going to break up left side and right side. So sine squared x divided by 1 minus cos x. And on the other side, we have 1 plus cos x. Right, so let's see what we can convert. Right? We have a cosine on the one side, we have sine on the other side, and cosine. We probably want to get rid of that sine squared. So looking at my identities, where do we see sine squared? Okay, we see it as 1 minus cos squared x. Right, so again, the Pythagorean identity. So we're going to use that to convert the sine squared x to 1 minus cos squared x divided by 1 minus cos x. Can't cancel anything out right now, but right, 1 minus cos squared x, I can actually rewrite that as a difference of squares. Make it 1 plus cos x times 1 minus cos x, all divided by 1 minus cos x. And now that it's multiplying, oops, sorry, we're cutting it off. Now that I'm multiplying, I can actually now cancel out this entire term with this entire term. What that leaves me with, well, 1 plus cos x. And if I look at the right side, that is what I had as well. So I can remove these identities. I don't need them anymore. And I have left side equals right side. So again, I've proven that sine squared x divided by 1 minus cos x is equal to 1 plus cos x. So again, a lot of these just take practice, just kind of going over them, seeing them, playing around with them. Think of those general kind of strategies that we talked about. Those general strategies that we talked about, right? Trying to change things to sine or cosine, finding a common denominator and combining the fractions, using difference of squares sometimes, or using our power rules. So again, this tends to be a little bit trickier, right? But I'd say the main thing is just make sure you're practicing, make sure you're trying these, playing around. Definitely keeping things neat and organized will definitely help so that you don't kind of get lost or get confused with what you've been doing. But again, definitely practice, practice, and practice.